Let's talk about discrete random variables. A random variable is a real valued function whose domain is a sample space. That's true, but that's not particularly helpful. That's a complicated definition. Here's an alternate definition. A random variable is a function which assigns a real number to each outcome of an experiment. For example, roll a pair of dice. If x is the sum of the dice, x is a random variable. Might be 2 or 10 or who knows what. If you shoot free throws in basketball, the number of shots you make is a random variable. Again, you have the experiment, and then whatever comes out of it, the number of free throws you make, that's going to be a real number. That's going to be your random variable. The weight of a cat and the age of a cat are random variables. Weight could vary, depends on the cat. Age depends on the cat. Here's our cat cupcake, decked out for the holidays. There are two kinds of random variables. There are discrete and continuous random variables. A discrete random variable takes on only finitely many values, or infinitely many values which can be counted. A continuous random variable takes on values in an interval. For example, are these random variables discrete or continuous? Height. Well, height can take on values in an interval, so height would be a continuous random variable. Weight, similarly, can take on values in an interval. It could be anything from 0 to whatever, so that's continuous. Number of children? That's not continuous. You can't have 2.57389 children. It's going to be 0, 1, 2, 3, 4, 5, 6, 7, whatever. That would be a discrete random variable. Temperature? That takes on values in an interval. That would be continuous. Number of cars owned? Could be a lot, could be a few, but it's not going to be 3.7. Number of cars owned is a discrete random variable. And age, whether it's measured in years or months, it's going to be a discrete random variable. So nobody says I'm 57.3829167 years. No, they say they're 57 or 52 or 12 or whatever. Notice that discrete random variables tend to be things we count. The number of children, the number of cars owned, the age, whereas continuous random variables tend to be things we measure, like height and weight and temperature. Let's look at a probability density function for a discrete random variable x. The probability that x takes on a particular value, little x, is often denoted f of little x, f of x. And f of x is the probability density function, or PDF, of x. In other words, f of x, f of little x, is the probability that the variable x takes on that particular value, little x. Sometimes we call f of x a density function or a probability distribution. For example, roll a pair of four-sided dice and calculate the sum x. Okay? So when you have a four-sided die like this one, it's a pyramid with a triangular base. In other words, it's a tetrahedron. The roll is going to be the number on the bottom. So in this case, you can see that the roll is 1. So let's say you roll a pair of four-sided dice and calculate the sum. Find the sample space. That is, in other words, the set of all possible outcomes. Well, if you roll 2 1s, you get 2. If you roll 2 4s, you get 8. Or you could get something in between, like 3, 4, 5, 6, 7. So this would be your sample space. 2, 3, 4, 5, 6, 7, 8. Find the PDF, f of x, or in other words, probability distribution. So in other words, we want to calculate the probability that x takes on particular values. What's the probability that x is 2 or 3 or whatever? Let's analyze it in this way. So let's look at the first die. You have these outcomes for the first die, 1 through 4. For the second die, you have these outcomes, 1 through 4. And then when you add them together, you end up with these outcomes. Each of these 16 outcomes is equally likely, and thus has probability 1/16. So let's calculate f of x for various values of x. What's f of 2? In other words, the probability that the sum equals 2. That would be 1/16. There's only one way to get a 2, 1 and a 1. Probability that the sum is 3 is 2/16. You can get a 1 and a 2, or a 2 and a 1. Probability that the sum is 4 is 3/16. Probability that the sum is 5 is 4/16. Probability that the sum is 6 is 3/16. Probability that the sum is 7 is 2/16. And the probability that the sum is 8 is 1/16. Okay, here's a summary. So here's our probability distribution. Here's our PDF. These are the values that x can take on, and these are the probabilities that x takes on that particular value. Let's graph the PDF f of x. You can use Excel to graph it. Here's what we end up with. Find the probability that x is greater than 5, that the sum is greater than 5. Well, the probability that the sum, in other words, is greater than 5, that means it's either 6, 7, or 8. Okay, so we want the probability that x equals 6 plus the probability that x equals 7 plus the probability that x equals 8. In other words, we want to calculate f of 6 plus f of 7 plus f of 8. When we look at this chart, we find that that's 3/16 plus 2/16 plus 1/16. In other words, 6/16. A probability density function f of x for a discrete random variable must meet these two criteria. 0 is less than or equal to f of x is less than or equal to 1. And why is this? This is the probability that our variable takes on the particular value x, and probabilities are always between 0 and 1. This Greek letter is a capital sigma, so when we see sigma of f of x, that means sum. Capital sigma means sum. So the sum of all the f of x's, in other words, the sum of all the f of x terms, has to equal 1. Let's look at our previous slide. These are the possible outcomes of x. Okay, those are the probability, and these are the probabilities here. When we sum up those probabilities, they all have to add up to 1. Okay, so the sum of all the f of x's has to be 1. Can this be a PDF? No, because f of 0 is 1.2. How could the probability that x equals 0 be 1.2? That makes no sense. Can this be a PDF? No, because the sum of the f of x's is 0.6. 0.1 plus 0.2 plus 0.3, that's 0.6. They have to add to 1. Find the value of k that makes f of x a PDF. Well, notice that we have 0.3 plus 0.3 plus k equals 1. Those probabilities have to sum to 1. That means 0.6 plus k equals 1. In other words, k equals 1 minus 0.6, or, in other words, k equals 0.4. So that's the value of k that makes f of x a PDF. By the way, the oldest cat ever is Cream Puff. Cream Puff lived to be 38 years old. Her owner fed her dry cat food, broccoli, eggs, turkey bacon, coffee with cream, and every other day a little bit of red wine.